Matter is anything that has mass and occupies space, and it exists in three states: solid, liquid, and gas. The state of matter is determined by the strength of the intermolecular forces between the particles that make up the substance. Intermolecular forces are the forces that exist between molecules or atoms in a substance. There are three types of intermolecular forces: London dispersion forces, dipole-dipole forces, and hydrogen bonding. London dispersion forces are the weakest type of intermolecular force and exist between all molecules, regardless of their polarity. They arise due to temporary fluctuations in the electron distribution around a molecule, resulting in an instantaneous dipole moment that can induce dipoles in neighboring molecules. Dipole-dipole forces exist between polar molecules and arise from the attraction between the positive end of one molecule and the negative end of another. These forces are stronger than London dispersion forces. Hydrogen bonding is a special type of dipole-dipole force that occurs between molecules containing hydrogen atoms bonded to highly electronegative atoms such as nitrogen, oxygen, or fluorine. The hydrogen atom in one molecule is attracted to the electronegative atom in another molecule, creating a strong bond. In a solid, the intermolecular forces are strong enough to hold the particles in a fixed position, resulting in a rigid structure. The particles in a solid vibrate in place, but they do not move around. Solids have a fixed shape and volume. In a liquid, the intermolecular forces are weaker than in a solid, allowing the particles to move around but not escape from the surface. Liquids have a fixed volume but take on the shape of the container they are in. In a gas, the intermolecular forces are very weak, allowing the particles to move freely and independently of each other. Gases have neither a fixed shape nor volume, and they will completely fill any container they are placed in. There are also two additional states of matter: plasma and Bose-Einstein condensates. Plasma is a high-energy state of matter that exists at high temperatures and consists of positively charged ions and negatively charged electrons. Bose-Einstein condensates are a state of matter that occur at extremely low temperatures, in which a group of bosons, particles with integer spin, form a single, unified entity. In conclusion, the state of matter and the strength of the intermolecular forces between particles are closely related. The three states of matter, solid, liquid, and gas, are determined by the strength of the intermolecular forces. The strength of intermolecular forces is determined by the types of intermolecular forces present, which include London dispersion forces, dipole-dipole forces, and hydrogen bonding. Plasma and Bose-Einstein condensates are two additional states of matter that exist at high and low temperatures, respectively.